This is R.D. Sharma Solution Class 12, Chapter 3 Binary Operation VSAQ, very short answer question. Question number 12. For the binary operation multiplication modulo 10, so x10 we are talking about, defined on the set S equal to 1379. So let me write this set 1379. Write the inverse of 3. So we know how to make the table now. You will be able to make it. Okay. So into 10, just write 1379 here, 1379 here, and I'll tell you few or one of the values 7 and 3 how to fill it. So what do? You multiply 7 with 3, that will be 21. Then you have to divide it by 10, and when you divide it by 10, the remainder you are going to write. That is 7, this 21, 10, division by 10. So this 1 is the remainder, okay? 10 twice, so 1 is remainder. 1 you are going to put. So 7 and 3, 1 you will put. Okay? Since it is multiplication, wherever 1 comes, what does it mean? It is also the inverse. 7 is the inverse of 3. And also the identity element. When the row and column, just see. I'll tell you one more value first, 7 and 9. So this will be 7 as a 63. You have to divide 63 by 10, and whatever is the remainder you have to write here, 3. I'm just trying to tell you how to fill this table. So wherever we have 7 and 9, 9 and 7, you put 3. Wherever you have 3, 7, 7, 3, just put 1. And likewise, you can fill all other entries. So once these entries are done, there are first row and first column. So what you have to find out is the inverse of 3, because inverse of 3 will only come when we know the identity element. Identity element is 1. Multiplication normally 1 is there. So first row, second row, they both are same. First column, second column, they both are same. Why they are same? Because 1 is the identity. Okay. Now this identity, so 3 is operated with certain value so that you get 1. So 3 is operated with what value? The first example I took. So it will be 7. So 7 is the inverse. Question number 13. For the binary operation multiplication modulo 5 xy defined on the set S equal to 1, 2, 3, 4, write the value of, let me tell you first, how are you going to make it? You have to write x5 here. This S is equal to, the set is also given to us. It's 1, 2, 3, 4. So now you know how to make it. So I'll tell you one of the value, say 2 and 3 we are taking. So 2 and x5 3 means you have to multiply 2 and 3, that will be 6. You have to divide it by 5, and the remainder you have to put. So 5 ones are 5. This 1 will be the remainder that you have to put. Right? Other values you are able to put. Okay. Now the question is saying about inverse, but there is an expression. So what is the expression? This is 3 into 5. That is 5 is the subscript, 4 inverse, and then the inverse. So what is the 4 inverse? As I said, this is multiplication. So the identity element will be 1. The first row and second row are same because the operation is with 1. First row and second column are same because the operation is with 1. So 4 operate with what value so that you get 1. That is 4 inverse is found. So 4 is operated with 4, then you get 1. 4 operated with 4, you get 1. So 4 is the inverse of 4. So in the place of 4 inverse, you are going to put 4. So 3x5, 4. Right? Now 3x5, 4. When you operate this, 3 and 4, what do you get? 2. So just put 2, and then you have to find out the inverse of 2. What is the inverse of 2? You have to do that is operation with 2 so that you get 1. So what is the 1 in this row? 1. 3, for 3 it is there. So 2 operated with 3 is 1, therefore 3 is the inverse of 2. Question number 14. On the set of integers, a binary operation star is defined by a star b equals a plus b minus 2. Write the inverse of 4. So as I said, this question was already being discussed. The second question is same as that. The second question and the 14th question are exactly similar in my edition. Maybe your edition also these questions are similar. So I'll just go ahead with the next question. So maybe the 15th is 14th here. That's the case. But you can just listen to what question I am going to do now. So the question is like this. Write the composition table for the binary operation x5 multiplication modulo 5 on the set S equals 0, 1, 2, 3, 4. So this S is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Now you know how to make it. I hope you'll be able to make it. Okay. So I'll tell you one of the values so that you know how to make it. So let us take 3 and 3. So 3x by 3 is nothing but 3 multiplication by 3. That is 9. Now you have to divide it by 5 and the remainder you have to take. So 5 ones are 5 and you get remainder as 4. Just put 4 here. This is the 4. Okay. Other value, I hope you will be able to do it. Next question is, a binary operation star is defined on the set R of all real numbers by the rule a star b equals under root a square plus b square for all a and b belonging to capital R. Write the identity element for star on R. So identity element is what? When you operate a with or a or b with any value, if that value is coming back, that is the identity value. So a star b is defined as under root a square plus b square. So a star e will be defined as under root a square plus e square. So now square both the sides. A square plus e square is a square. So this e square, because a square gets cancelled, e square is equal to 0. That is e is 0. So 0 is the identity element in R with respect to this star. Okay. Next question is, let plus 6 addition modulo 6 be a binary operation on S. S is given by 0, 1, 2, 3, 4, 5. Write the value of, there is a whole expression here. So first, you know how to make the table, but because it is plus 6. So you have to add and then divide by 6 and then you have to put the remainder or the modulo. Okay. So 0 to 5 you have to write in the row and column, then you start operating. So let us take an example. 4 and 5, how it is coming. So 4 plus 6, 5. That is 4 and 5 you have to add. So 4 plus 5 is 9. Then you divide it by 6 and find out the remainder. So 6 ones are 6, 3 is the remainder. This is 3. And the first row and second row are exactly similar. First column and second column are exactly similar. That means 0 is your identity element. Now the actual value we are going to write, that is the expression 2 plus 6, 4 inverse plus 6, 3 inverse. So you have to find it using the table. See, 4 inverse, the value which is operated with 4, it should give 1, if it should give 0. Because the identity element is 0. So it is operated with 2 to get 0, so 2 is the 4 inverse. What is 3 inverse? 3 is operated with which value so that you get 0? It is 3. So 3 is there. Now 2 and 2 will operate. Just take the row of 2 and column of 2 and find out the intersection. That is what you have to do. So 2 intersection is your 4. I am saying 2 plus 2 is 4. 4 divided by 6 is what? Because the 4 is less than 6, so you will just write 4. Okay. Then you have to do the 3. So just look at the table 4 and 3, what they are intersecting. That is what you have to write. Okay. So 4 and 7 is 6. 4 and 7 is 4 and 3 is 7. 7 divided by 6 and 1 is the remainder. Next question is, This is CBSE 2008. Let star be the binary operation defined by A star B equals 3A plus 4B minus 2. So we have to find out 4 star 5. So in place of A just put 4, in place of B just put 5. So 3 into 4 is 12, 4 into 5 is 20, 12 plus 20 is 32, 32 minus 2 is 30. So 30 will be our answer. Next one is saying, let star be a binary operation defined by A star B equals 3A, A star B is 3A plus 4B minus 2. No, it's A star B is 3A plus 3B square. I am taking the next question here because it is CBSE 2009. Okay, so the question is A star B is A plus 3B square. We have to find out 2 star 4. So just put A as 2, B as 4. So A as 2 plus 3 into 4 square is 16. 2 plus 16 into 3 is 48. 48 plus 2 is 50. Then the next one. Let star be the binary operation on natural number n given by A star B is HCF, highest common factor of AB. AB is belonging to n. Write the value of 22 star 4. So just find out the HCF, highest common factor of 22 and 4. So what are the factors of 22? You have to find out the HCF of 22 and 4. So common, just find out the factors of 22, find out the factor of 4, highest common factor, just write. So 22, the factor are 1, 2, 11 and 22 itself. So I'm just writing 2 and 11 because 1 and this 22 is already there. 4 is 1, 2 and 4 itself. 1, 2, 4. Okay, so what is the highest one? 2. So 2 is the answer. So the previous question was 2009. Now this is CBSE 2011. Let's start with the binary operation on set of integers I defined by A star B is equal to 2A plus B minus 3. Find the value of 3 star 4. Put A as 3, B as 4. 2 into 3 plus 4 minus 3, that is, this is 10 minus 3, that is 7. This is the final value. Okay, this is all about this exercise. Thank you so much. Take care of yourself.